We're starting already. I'm recording, so I'd appreciate it if I had your undivided attention. Pause. Okay, chapter 2-7. This section is all about graphing rational functions. Whenever I say graphing a rational function, that means there's a whole lot going on. Okay? There are several steps because you want to get as much information out of this lovely thing as you possibly can. Do you remember last time I gave you worksheets? They look exactly like your test. Remember that? What do you think this worksheet looks like? Exactly like your test is going to look. Okay? So now, what this means is I want you to, step 1, simplify this thing if possible. Step 2, find and plot the y-intercept, let x equaling 0 and solve for y. Find and plot the zeros of n of x, which n of x is equal to 0. That's how you find it. Find and draw with dashed lines your vertical asymptote. That means d of x cannot equal 0. And then find and draw your horizontal asymptotes, which means you're looking at the degree of n of x and the degree of d of x. With me? And then plot points between all of the above to finish off the graph. Now, those are all the steps. But just like in section 2-6, step 1 we did domain, right? Step 2 we did vertical, step 3 we did horizontal. It's going to do the same exact thing. 2-7 we throw one more little thing in, and that little thing is going to be what we call a slant asymptote. Okay? Now, let's get busy with it. You ready? Step 1, domain. How do I find the domain? Right here. Okay. Domain. D of x cannot be 0, right? So that means x minus 2 cannot be 0, so x cannot be 2. Correct? So this means x is now on the reals, and x cannot be 2. What does this mean graphically? There's a hole at the value 2. There's not a y value corresponding to it. Do y'all understand that? Okay, from here, I now want to find my vertical asymptote. My vertical asymptote says that I need to simplify my function. Can I simplify 3 over x minus 2? No, so I'm done. I cannot simplify it. So my question now is what is my vertical asymptote? My vertical asymptote is now taking d of x in its simplified form and setting it equal to 0. Well, since it's already simplified, I'm simply going to take my denominator, which is x minus 2 equals 0, and then solve for x. And if I do that, what does that give me? X is equal to 2. Which means now I have this dashed line, vertical dashed line at 2. Do we all understand that? So not only do I have a hole in the line, the graph there, I have an asymptote, meaning what is an asymptote? It's not a point. It is a line where it gets really close to the line, but it never crosses. Do we understand that? Okay, excellent. Now the next thing I want to find is going to be my horizontal asymptote. How do I find a horizontal asymptote?
Look at the degrees.
We look at the degree of the top, which is what? 0 because there's no x. Since there's no x, that means the degree is 0. What's the degree of the bottom? The degree of the bottom is going to be 1. So now what I'm going to do here is I have n is equal to 0 and m is equal to 1. And what is the relationship between n and m? N is less than m, which would imply what about my horizontal asymptote? That y equals 0 is going to be my lovely little horizontal asymptote. Well, what does this look like on the graph? What does this mean? I have this vertical dashed line going on at 2, and now I have a horizontal dashed line going on at what? 0. Do we see that in our head? Can we see it? Okay. Okay, well now we're going to continue on. This is all from section 2-6. Everything I've done so far is nothing but review. Agree? Now let's go back here and actually think about other things we need to find. Well, then number 2 says to do what? Find and plot the y-intercept. Well, by definition of y-intercept is the point on the graph where it crosses the y-axis. If it's crossing the y-axis, what does x have to be? crossing the y-axis, what does x have to be? It has to be 0. So I come back over here and I'm going to find my y-intercept. That means I'm doing f at 0. Okay? Well, my function is 3 over x minus 2. So every place I see an x, what am I plugging in? I'm plugging in a 0, so that's going to be 0 minus 2 to give me negative 3 over 2. Now, what am I actually, whenever I evaluate, what am I actually getting out? When I evaluate a function at a value, what am I getting out? I plugged in a value for x, what do I get out? A value for y to create a point. And that point is going to be the point 0, negative 3 over 2. That is what's important. Because now what your brain needs to be seeing on your graph in your head is this dash line down 2, horizontal dash line at 0, and now at 0, negative 3 over 2, you are going to have a point there. Does that make sense? Yes or no? Okay, well now, let's go ahead and add those on your graph paper. Let's go ahead and add those. We already said I have a vertical asymptote at 2. Do you see that? I know it's so cheating. Draw it on your paper. Nice little vertical asymptote. Use your ID to help you out to draw a straight line. The one you're all wearing, right? And then do a horizontal one right there. And now what's the point that I should be graphing? What is 0, negative 3 over 2? And what is that? Negative 1.5, right? 0, negative 1.5. Do we understand that? So now this is what we got going on so far, right? And I totally did not graph that right. I went down one.
I was like, what are you doing?
I accidentally was going off the red line instead of the black line. Sorry. Do we see that?
Actually, they go blue, red, blue, red.
I hate it today. Okay. Correct. Okay. Okay, so now I have my y-intercept. So now what do I need to find? My x-intercept. How do I find my x-intercept according to this thing? Find and plot your zeros of n of x. Well, your zeros of n of x mean I have to take n of x, my numerator, and set it equal to 0. So if I do that, what's my numerator? I need to find n of x is equal to 0. So that means 3 is equal to 0. Is that true or false? That's false, which means do I have an x-intercept? Well, by definition of an x-intercept, it's the point on the graph where it crosses the x-axis. Well, this is going to be completely ironic considering our x-axis is actually our what? Horizontal asymptote, right? It's our horizontal asymptote. If I have an asymptote on the x-axis, am I going to have any intercepts? Let me repeat that, slower. If I have my x-axis, which is y equals 0, as an asymptote, am I going to have any points on this? No, because that will defeat the point of being an asymptote. Do we understand that? Okay. So now I have found the y-intercept. I have no x. Did I do my vertical asymptote? Yes. Did I do my horizontal? Yes. Now it says step 6. Plot points between all of the above to finish off the graph. Now, do I expect you guys to do this all by hand? Now, what you want to do is you want to look at this and say, what is this thing going to look like? What's my gut instinct telling me? Without graphing it, what I want you guys to have a good idea of saying is, I think I have to go through this point right here. If I have to go through that point, what's going to happen? Can it cross the y equals 0? Can it cross x equals 2? So what do you think is going to happen? It's going to curve just like this. Do we see that? Right? Now, what do you think is going to happen any place else? Keep in mind, rational functions are generally symmetrical. Let's go do it at the top right corner. You see that? That's what it should look like. So how do I confirm that? I confirm that by simply pulling up my graphing calculator. I come over here. I'm going to graph this function. My function, I do control division key, and I have 3 over what? X minus 2, and hit enter. Well, there's my lovely little function. Were we correct? We absolutely were. Now, we need to come up with some nice, neat ordered pairs to graph to make our function legit on our paper. So, do we want to do that by hand? No. The calculator does it for us. You're going to hit Control-T for table. You want to get positive values and negative x values. So I want everybody to pull this open on their calculator and tell me what lovely little points do you think that you should graph. As I look at this, on the negative aspect, what's some easy numbers to graph? I see -2 and negative points. -2 and -3/4. Can my eye kind of eyeball that pretty well?
You're looking at the table to graph.
I'm looking at the table. Go to the negatives. Arrow up on the negatives. Okay. Now, what's another one that you should use? -1, looks good to me. What's another one that you could use?
1 and -3.
1, -3 looks good to me. What's another one? Now we're in the positives. So what's another one you should choose?
33.
3. Give me another one.
5, 1.
4, 1.5. 5, 1 looks good to me. Do you see that? So I've chosen those values. Now I'm going to actually graph them. I'm going to cheat. I'm going to bring this over. So I'm going to plot these points. It was -2 and -3/4. So I'm at -2, -3/4, puts me there. I'm at -1, -1, puts me there. I'm going to be at 1, -3, puts me there. Does that look legit? Can we see that it's going to happen to be like this? I think you get a pretty good indication using those points. Now if I go on the other side, 3, 3. And then 4, 1.5. And then 5, 1. And we can see the curve of this line too. Does everybody understand what I want? Yes or no? You don't see that? You don't see those points on your graph?
So you have to have a name.
You got to enter in the function correct.
Sure. Jackass.
Jack? Oh my God, that's funny! Oh, I gotta tell this stuff. All right, there.
You're like, look great.
4, 1.5.
Why are you looking at me for?
Okay.
Yeah, would you stare at me?
Okay.
Oh.
He has
Now.
Yeah.
We're going to skip down and we're going to go to this slide right here. Slant Asymptotes. We're going to skip a few pages here. That slide right there.
I would
There
say.
now, slide before you have oh,
That's not me.
yes, it really was. Okay. Now, we're going to add another concept to this. The other concept is going to be a slant asymptote. A slant asymptote only exists when the degree of the numerator is exactly 1 unit larger than the degree of the denominator. Do you understand that? If it is 2 units greater, do I have a slant asymptote?
No.
No. If it's 1 unit greater, do I have a slant asymptote?
No.
If it's 1 unit, yes I do. If it's 1 unit smaller, do I have a slant asymptote? No. It's only when it's 1 degree larger. Do you understand that? Now, for example, what's my degree of my numerator? And it's 1. What's my degree of my denominator? 0. Do I have a slant asymptote? Yes. This one. What's my degree of my numerator? 3. What's my degree of my denominator? Do I have a slant asymptote? No. We all understand that? Yes or no? We good? How do I find a slant asymptote? Well, the way we're going to find it is by doing long division.
Oh.
Give me that shred of Yeah. I now want you to synthetic division. I want you to do the long. The equation of the slant asymptote is going to be y equals your answer without the remainder. So do I care about the remainder? No. Now I'm going to insert a page here. If I have 2x cubed minus x squared plus 1, all divided by x squared minus 1. Because I need that for something. If I need to do long division, I put this on the outside and 2x cubed minus x squared plus 0x plus 1 on the inside. Do we all see that? What do I multiply x squared by to get 2x cubed? 2x. So 2x times x squared gives me 2x cubed. 2x times 1 gives me minus 2x. And what do?
Wishbone.
You subtract. And when you subtract, you change the signs.
Erase pretty well.
That's gone. I bring down the negative x squared plus 2x plus the 1. Now what do I multiply x squared by to get negative x squared? A minus 1. So negative 1 times negative x squared gives me a negative x squared. Negative 1 times negative 1 gives me positive 1. Yes? Now what do? I'm subtracting a quantity, so the signs change. That's gone. I'm left with 2x left. That's it. Do I care about the remainder?
No.
No, I don't care about the remainder. This, I don't care about. What would be my slant asymptote here? Y equals 2x minus 1. Now, how do I graph a slant asymptote? This is y equals mx plus b, right? So what's my b? The point 0, negative 1 is where you start from. And what's my slope? 2 over 1, which means it's rise over 1. Remember? And if I say please rise, that means you're going to go up 2 units. If I say run, if it's positive, you're going to run to the right. If it's negative, you're going to run to the left. Since it's positive, I would go right here. So what this means is if I want to graph that,
Where'd you get your 0, negative 1?
that's your b value
Where?
right here, minus 1. Mx plus b. Okay? So I would start at 0, negative 1, and from there I would go up 2 units and to the right 1. Up 2 units to the right 1. Up 2 units to the right 1. There's your line. That would be your slant asymptote, but you would make that a dashed line. Do you understand that? Now you got my line all with me.
Yeah, okay.
I thought you were saying.
Hold on.
Why don't you bring
Okay, now what is your concept? I'm really glad you do. Okay, now, let's move on to this one. What? What? Well, she doesn't say anything, she just gives me a look, and I'm supposed to understand what that look means without her saying something.
That's like Matt when you go.
Okay, now, we're going to do every single thing like we did in the last one. Pay attention. Step one, what do I do? Domain.
I was friendly with guys.
Domain. D of x cannot be 0. So x minus 1 cannot be 0, so x cannot be 1.
I don't even look at the board, I just listen. That's what I'm trying to do, but it's still not fun. I'm walking on. Stay over there.
They need like a speed limit on this thing.
What did he say?
Want me to walk it like this?
Somewhere far away, so I can hear.
Who picked art? Say next
That's my domain. Now what do I do next? Vertical.
Pick art.
Where do you go on the stage?
Vertical, what do I do? Can I simplify this? Can I simplify it? I need to try. I can factor this, x minus 2 times x plus 1, all over x minus 1. Does anything cancel out? No, since nothing cancels out, I'm literally going to take d of x equal to 0, so x minus 1 is equal to 0, so x is equal to 1. That is my vertical asymptote. Agree? Horizontal asymptote.
Is that equal sign?
Yeah. Now, what is my degree of my numerator? 2, what's my degree of my denominator? 1. Since n is greater than m, do I have a horizontal asymptote? No, this is going to be none. However, what can we get out of that immediately? But now I know I'm going to have a slant asymptote. How do I know that? How do I know that?
This,
Because the numerator is 1 unit larger than the denominator, right?
yeah.
So how do I find my slant asymptote? I need to do long division. X squared minus x minus 2 goes on the inside, and x minus 1 goes on the outside. So what do I multiply x by to get x squared? X times x is x squared. X times negative 1 is negative x. What do I do? Subtract them, which means the signs change. Those cancel out and left with negative 2. Can I multiply anything by x to get negative 2?
I'm lost.
So now, do I care about the remainder?
Should be.
No, I do not care about that. So what's the equation of my slant asymptote? Y equals x is my equation. That's my equation of my slant asymptote. How do I graph that? I'm listening.
Oh, I remember this, but I forget.
That's a plus and that's a minus. One plus. Because you have to change the sign. Because x times negative 1 is negative x. Okay. Now how do I graph y equals x? No, it's slant. By definition, it has an x and a y in it. It has to be slant. No, you do not put it in the graphing calculator. What's it's right here? What's b? 0. So I'm going to start at 0 to 0. And what's m? 1. So that means you're going to go up 1 to the right 1. Do we understand that? Now we're going to stop right now and we're going to graph our asymptotes.
0, 0. 0 to 1.
You start at your y-intercept at 0, 0, and you're going to go up 1 to the right, up 1 to the right, up 1 to the right. So the first thing that I want to graph is going to be my slant asymptote. That way you guys don't have other points on there and freak out. There's slant asymptote. So I start at 0, 0. From there, I go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Do we all see that? Yes or no? I connect it with what type of line? A dotted line.
Bless you.
Bless you. Please keep your germs to yourself. Now, erase your points. Do we see my slant asymptote? Do I have any vertical asymptotes? What was it? What was it? X equals 1. So now I'm going to do my nice little slant asymptote at 1. You guys are so jealous, aren't you? That's a vertical asymptote.
No, she said she's doing vertical when she showed her.
Sorry.
Oh, yeah. Not.
Like, sneaking at look.
You do.
That would be a lie in itself.
So now, I have my vertical, horizontal, and slant asymptotes graph. Now, what else do I need?
No. It's my little cousin.
I need to find my y-intercept. So how do I find my y-intercept? How do you find your y-intercept? You do f at 0, which f at 0 is this function. In every place you see an x, you plug in a 0. So what's going to happen to those zeros there? They're gone. I'm left with -2 over -1. And what is -2 over -1? 2. So what are we actually getting out of here?
Y equals 2.
Y is 2, but I plug in 0 for x. What do I get out? So I have to plug 0, 2. So go back over to your graph. What do? I plot the point 0, 2. Let's be right there. Yeah, I'm going to. So there is my lovely little y-intercept. So now, what do I need to find? X-intercepts. How do you find x-intercepts? Those are found by doing n of x is equal to 0, right? So what's n of x? X squared minus x minus 2. So what do I do? Put in two binomials. X minus 2 times x plus 1 is equal to 0. X is equal to 2, x is equal to -1. So now what do I have? 2 more points. What are those 2 points? 2, 0, and -1, 0. So what do? I go back to my graph. And I'm going to graph the point 2, 0. And what was the other one? -1, 0. Now look. I have to put every single thing on my graph that I possibly can at this point, correct? What is your gut instinct telling you this thing's going to look like? I can feel it. What is your gut instinct telling you this thing's going to look like? Well, these things are going to connect, don't you think? Probably going to look like that, right?
Across the line.
Pretend it.
They know.
And then this one's probably going to look like this, right? That is what it's going to look like. So we have to find out if we're right according to our lovely little graph. So I come over here.
Give us a recording.
So I had a graphs page, and I put my division in. X squared minus x minus 2 over x minus 1. Enter. Are we right? Look at that. Okay, now what do I do? Control T. Why do I want Control T? Now I want to pick lovely little table values that is going to work for this thing so that I can actually graph and say, yes, this is what it was. Correct? I just control I control T all the time.
You use this drawer?
Yeah. Oh, I did mine coming down just yesterday. So now I have an XY table. Okay? And now look at this. If I'm looking at negative values, what do you think you're going to choose?
-3 and 2.5.
Negative 3, negative 2.5. What's another one?
-1 and 0.
You already got it. Negative 7, negative 6 and 3/4. So go on the positive side now, and what do you pick?
0, 2.
Already got it.
2, 0, 3, negative.
3, 2, what else? And if you want to do, you could do 9 and then 8 and 3/4. Now we have all the values that we're going to use right now, right? So I take all of this, come over here, and I'm going to paste that in, and I'm going to graph it. So I'm going to graph it like negative 3, 2.5. So I'm at negative 3, and then negative 2.5. Puts me right there. I'm going to graph negative 7, and negative 6, and 3/4. That puts me right there. So I now know that this is going to look like this. Do we see that? Go on the other side. 3, 2. So now I have 3, 2. That puts me there. The other one was going to be 5. And then 4.5. Puts me there. My next one was going to be 9. 2, 4, 6, 8, 9. And then 8 and 3/4. 2, 4, 6, 8 and 3/4. Puts me there.
Why did that first?
Do you see it? Does that make sense? Very good. I'm really glad to make $. Okay, I'm going to give you your worksheet for tonight. You have 10 problems. Graph paper is behind Alec back there. How many are on there?
Here's what I've done.
Enough?
Screen and rip off. Do we need to stop this?
Either.
Hey, can we stop this? Stop or pause?